Okay, I think this is working now. Um, so I'm gonna do uh, a LeetCode problem today and see how things go. I'm gonna try to do one that's blind here. Since this is the first one, I'm fine with going with an easy one, just a random one that I haven't touched yet. This one is remove element. I haven't seen this before, but we'll just start and see how things go. Uh-oh, there's a heavy amount of dislikes. I wonder why. So, given an integer array nums and an integer val, remove all occurrences of val in nums in place. The relative order of the elements may be changed. Since it's impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. Okay, normally if there are k elements after removing duplicates, then the first k elements of nums should hold the final result. Okay. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the k slots of nums. Okay. In the first k slots of nums. Do not allocate extra memory space for another array. You must do this by modifying the input array in place with constant memory. Custom judge. The judge will test your solution with the following code. Okay. If all assertions pass, then your solution will be accepted. I wonder if this is old, because this seems like it's... I don't remember LeetCode doing stuff like this. Here's how you judge kind of thing. An example 1, 3223. I imagine, yeah, 2, 2, and then these should be whatever. I wonder if these will need to do, I'll need to do some swapping here. Your function should return k is equal to 2, with the first two elements of nums being 2. It does not matter what you leave beyond the returned k, hence they are underscores. Let's see. So this one, if the val is 2, so we need to remove these two and this one. So then all of these are going to be here. But it doesn't matter what order they're in, as far as I understand. Yeah, it does not matter what you leave beyond the return k. Okay. So it's not going to need to, it doesn't need to be sorted or anything. So, if this were a normal interview, I guess I'd ask, is there anything, so I'd ask about the constraints here. So, like how long is the array going to be, or things like this. I would make sure that I'm not assuming that this array can just be whatever when it's returned, the first part. It doesn't need to be sorted or anything. So this looks pretty simple here, right? So we know that we need to just slap these ones on the end. This is almost like a sorting algorithm, but it's just um, the only heuristic is whether or not the list items are equal to this value that is given. So, and we know we need to put them on the end, so we can actually just have an end index. So if we keep a pointer that starts at the end, whenever we go through starting from the beginning and we find any number that is equal to the value, then we can make a swap from wherever that pointer is that starts at the end and where we saw that, and that'll put it at the end, and then we decrement the pointer. So that's what I'm going to try to do. So from what I was reading, I need to kind of, maybe I'll start off by saying, let's just actually go through. So for Let me see. Is there anything that I need to do before I start coding? Because sometimes I go too quickly through and then I realize that I have some kind of corner case. But I don't think that's the case this time. I think this should be fine. So let's do end index is equal to length of nums minus 1. And so that starts at the end. Now we're literally just going to go for I in range length nums. And now we're going to say if let me do this in traditional snake case like Python. I have a bad habit of naming variables like I'm writing in JavaScript. So if nums I is equal to val, so we want to see if we found the val. If that's the case, then we're going to make a swap. So what we're going to do is temp is equal to nums I, and then we're going to put nums in end index is equal to I should say nums I is equal to nums end index. So, and then we're going to put nums. Do we even need to worry about swapping the other one? Oh, so I guess this does matter. So here's a something that I didn't think about, right? So we need to, if we've made a swap and then we keep moving, then in that we'll have an issue where we won't check that number at the end. So what I mean by this is, in the way we're doing it now, so imagine we have 3 here, we're going to check 3, see if that's equal to the value. If it is, we're going to swap these here. So we're literally just putting a 3 back into the same spot, and then we move on. So that is a problem. That's something that we need to handle, right? So, what then is the best way to handle this? Let's see. So now that I'm thinking about that, maybe it's better to, I'm trying to think of the best way to make sure that I'm actually handling those numbers when we do make a swap. And maybe actually the best way to do it then is to be checking these already. So maybe we're actually starting from the end here before we make a swap. So we check if this is 3. If it is, then we will, swap it with, actually, that's the correct index, but we're going to move both. The range is going to decrement, and then also the end index is going to decrement, and then we check. I think that'll work. I just needed to reverse the order that we're checking these values here. Okay, so I actually think that should be fine. And then nums end index. This is not necessary. In fact, it's an extra step, so we will just ignore it entirely, right? Because we're taking nums I is equal to nums end index. So that is the, let me make sure I'm doing that correctly. So let's imagine here we're looking at this. This is the 2. And, well, let's imagine we're going through this way. We've already seen this 3 here. We're going to swap this. Oh, yeah. I think that will do. Okay, so we're going to do nums I is equal to nums index, and then end index. We're going to decrement end index. So, I think that's all we need to do for that, and then we will just return. Are we returning k? Maybe I missed this. What is it that we're returning? Returning k after placing the final results in the first. Oh, okay. So we're returning the end index here. So that's good. We're already keeping it in place. So yeah, I think that will be it. I think that's it. Well, the question is, if we have an empty array, what do we need to return as the end index? Will it just be 0? If that's the case, maybe the first k slots, does that mean I need to add +1 here? Maybe that's because this is now the length, because we're indexing here, but then now we need to know what the number of slots there are. So maybe let's try that. Let me put in some examples and see if this runs correctly. So we have this test case in here, so let's try to run it. It looks like it worked successfully. That's good. Let's try just some of these, and then I'd like to try some corner cases and see if we have run it correctly. Value is equal to 2. Okay, looks like that worked all right. The output that they are giving is a little bit different than mine, but this should be linear time here and constant space. As long as yeah, it's always constant space. So the one that I wanted to check is something like an empty string. Do we have any issues with, or an empty array? Do we have any issues with that? No, it looks like everything's fine. It's odd that they're showing an expected output as an array, even though we're returning an integer. Maybe that's why people are this is kind of confusing for some people, is that the way they're judging this is in a way that it checks the list, but what in reality you're returning the bound of the list where you've removed the elements. So I think we're good here. I think this is good. I'm going to go ahead and submit it and see if it worked. Okay, looks like it was good. Looks like everything came up correct. I'm going to submit it one more time. It's funny how much sometimes these vary, this runtime and memory usage from one run to the next. It'll say, hey, yeah, apparently mine went from being middle of the road runtime to absolutely incredible runtime. So, but then the memory usage is so-so. So there's a lot of variance there, but it looks like we have a very elegant solution. So that was actually pretty simple. I think I'll go ahead and slap another one on here. And to just pick from the list, I guess we can just grab another easy one. We can sort by difficulty, or I'd prefer to sort by this list of how LeetCode has it sorted. But I'll just go ahead and grab another easy one, and we'll just go ahead and try to knock it out really quickly. So this one is very highly rated, so let's try this. Given a sorted array of distinct integers and a target value, return the index if the target is found. Okay. If not, return the index where it would be if it were inserted in order. You must write an algorithm. Okay, so this is binary search. I need to brush up on binary search here because I'm a little bit rusty on binary search, but I think that I could do it from memory, or at least based on my understanding of how binary search works. Um, so we will need to know, we'll probably need to keep track of a couple things here. So when I'm looking at this, we will need to keep track of, obviously we're gonna do binary search. That's a given, right? There, this is just for the most part binary search. But what's going to change here is we need to detect when it's not in here, and when if it's not in here, it's and we're going to give where this new target value would be placed into the array. So it's always going to have an integer input, whether or not it's found or not. So like this one, it would be placed in between here, so it would be an output of 1, index 1. Okay, so I'll go ahead and look at the constraints. I don't think they're... Nums contains distinct values that are in ascending order. So I wonder if the distinct matters here. I think distinct just makes it a little bit simpler in the fact that you don't have to handle multiples to find the target index of where you would actually put this new value. So let's go ahead and, so for binary search we're going to need a left index and then we're going to need a right index. Right index being equal to the length of the list minus 1, and then the left index being 0. So while this is going to be while left index is less than right index. So if so we're going to go let's see, we want to target the element here, so it would be the middle of these, obviously. So we're looking for the left index minus, or I should say the right index minus the left index divided by 2 would be the index that we're trying to search for in the middle. So let's do that. So in this, like for example, in this case, right, we start at 0, and then we'll start at 3 here. This is index 3. So if we do 3, 3 minus 0 is 3, divided by 2 is 1.5, and then we round down, we floor that. So I believe in Python you can use double division to just floor something to make it an integer. So that's what I'll be doing. So then we start at 1 here. We would start at index 1. So let's try that. So val current val is equal to, and I really need to like make sure I should absolutely be having no issue in figuring out binary search when I'm doing these problems. So I'll go back and make sure I definitely know this stuff. So right index minus left index, and then we're gonna divide that by 2. So that would be nums this index if current val, or I should say target is equal to current val. Let's do this real quick. Equal to current val. Then return this index. Actually, it's probably better to just do this index current index is equal to, and then I'll just save the index as a variable, so I don't have to reference it again. Nums current index. Okay. If target is equal to nums current index, then return current index. Okay. Else if target is less than nums current index, then if it's less than, then we need to go shorter. So we'll need to decrement the right index. So that means we need to have the right index, or at least where it is. So have it based on where the left index currently is. So I think we make the right index equal to the current index. I think that's the best way to do it, right? So right index is equal to current index. And then else, and then we do the same thing for left index. If that's is equal to current index. And then right at the end here, I think we could do just this. Yeah. Left index is less than or equal to right index. I think we can let that go. So if they pass each other, actually, what we should do, I don't want this to go through the while loop while they're both on the same index, because if they are both on the same index, then I could be confused on how binary search. I think that while this, if it runs like this, then inevitably, if the value is not found, they will land on the same index, right? Like eventually the left index will equal right index, and it won't pass it. It won't pass. There's no instance where they're pass each other. So if that's the case, then we just need to check if nums left index or left index, since they'll both be equal to, hopefully, left index is equal to val, or I should say target. Then if that's the case, then that means that that's what we return left index, right? Else, what we need to do then, if it's not, then we need to, let's see, if it's less than, we return, okay, oh, let's see, or nums is left index. Oh, I can just do this. If it's less than or equal to target, and what that does is, let's say in this example here we have 1, 3, 5, 6. This 2 is not in this, right? So we eventually narrow it down to where we're here at index 1, and we know for a fact that target is not in it. Or maybe we're here at index 0. But either or, we could be at either or of those. If it is, or we'll check and see if this is equal to. If it is, obviously we're returning that index. But if it's less than this value, that means that we are also returning this index, because this is where we'll place it if we needed to place it there. So we can just say less than or equal to the target. So, and then if all else fails, of course, we're going to return left index plus 1, because that means that we'll have to place it next, above, like, we're placing 2 ahead of 1. That would be, we're checking this, we're adding it into the next index above. I'm going to look over this to make sure that I'm handling this correctly. I also realize now that I'm not, am I changing these correctly? I think I am. But let's go through this example by hand just to test this, right? So while left index is equal, so this starts out as 0 and 3. I'm using this one as an example here. So we have, let me, 0 and 3. And so this will check 3 minus 0 divided by 2, and then floor it. So that's 1. Current index is 1. And then it checks if 1, which is 3, if it's equal to the current index. So 2, if 2 is equal to 3, it's not. So then it checks, is the target number less than the current index? So in this case, it is. So then it'll change the right index to the current index, which was 1. So now the left index is 0, current index is 1. And then the other, it won't go through here. And then we go through the loop again because they're not, left index is 0 and right index is 1. It does this 1 minus 0 divided by 2 and floor it, so then that will be 0. It gives index 0. It checks here if if this index 0, which is 1, is equal to 2. It's not. Then it checks, is it less than, is this amount, this number, is 1 less than, or is 2 less than 1? And that's not true, so it's going to go through here, and it's going to make left index equal to the current index, so 0. Oh. And then it looks like we actually will have an infinite loop here, right? So I actually need to make this say current index plus 1, right? Is that correct? And then for this one I might even need to add minus 1. Is that correct? I think so. I think that, because that would have been an infinite loop were I to not do that. I think that's true. So now I'm feeling confident in kind of trying this out. Um, we have an issue here because else if, oh, of course, elif is the correct syntax for Python. So let's try to run this here. We've got the test case of 5, which would have an output of 2. Let's see how it runs. Looks like maybe this is taking a very long time. Are we having an infinite loop here? Yeah. So maybe we've got an infinite loop in this case. That's odd. Okay, so let's check why that might be. While left index is less than right index. So I'm going to use this one as an example. So it's going to check, it's going to start by checking this. It'll check index 1, right? It'll check index 1. It'll say, oh, okay, it'll go down to this one because it's not, or I would say the target is not less than 3 because 5 is not less than 3. And then it would come here and it would make the left index equal to the current index, which is 1, and it would go to 2. So we've got 2 and 3 here. Okay. I feel like I'm seeing where there might be a problem. Because now I'm not indexing this correctly. This is like an improper way of doing it. Is that right? So, let's see, because this now goes in where left index is equal to 2 and right index is equal to 3. So we've got these right here. So this comes in and says 3 minus 2, which is 1 divided by 2, puts it at 0. So this is totally incorrect how I'm handling this right here. So, man, I need to handle the right index and the left index properly. So what is the way you're supposed to do this? 3. So I want to actually get 2.5, and then so would that be right index plus left index? So that's 5, because it would be 2 and 3 divided by 2 is 2.5. This needs to be plus. Is that what I'm seeing here? 3 plus 0. I think that might be the problem. Yep, that's the problem. It was just a simple issue with this. But let's make sure that was the problem. So they give us another example, but then they said 2, and that should give us, oh, we got the wrong answer here. We got the wrong answer here. So let's figure out why we got the wrong answer here. Now we have to go through here. We have to trace through here and figure out why. We start out 3 plus 0 divided by 2 is 1.5. It goes to 1. We know this, which means it will also check whether or not this is 3 is smaller than 2, which is not the case here, so it'll go over here, and it will make left index equal to current index, which is current index plus 1. That doesn't sound right. Let me see. If the target number is less than num's current index. I think I'm doing these backwards. Am I doing this backwards? Num's current index. So we're looking for, oh, the target is 2. Is 2 less than 3? If it is, then, oh, no, I'm sorry, it'll hit this, right? So it will make the right index equal to 0 here. Yep. So then they'll immediately go, since it's 3 and 0, it checks 1, and then it realizes that it's too big. Then it'll put the right index to 0. So then we immediately leave the loop. They're both 0. It checks then if this is less than the num's index. So I think this is the one I'm doing backwards here. If the target, which in this case is 2, target is still less than or equal to, yeah, let's run this. Num. I meant to do nums. Let's fix that. And then run again. Yep, that seemed to be the problem. I'm going to go ahead and fill all these in, or give these all a shot. These test cases, these example cases, are a little lacking. They're all the same array, but we'll try some corner cases. Yep, that looks correct. We want 1, and then the target is 0. That should come with an output of 0. Okay, yep, and then let's just try an empty array for good measure. This might cause some problems. Yep. Oh, actually this is just an invalid test case. It will always have at least one number. Okay, so we don't even have to worry about that test case. Okay, so it looks like this is good. I'm going to go ahead and submit it. Maybe there will be something wrong, but we'll see. Yeah, this actually turns out excellent. So this was binary search. Unfortunately, I have not implemented binary search in probably well over a year or two. So I kind of had to crash course, remember, okay, here's how you implement binary search. But this was essentially binary search, and then we have just some extra flair over here to add in where the target index will be if you were to insert this value. So yeah, there are two coding questions that are down. I know these were easy, but hopefully that was not bad. I think that second one was a little bit more iffy just because of the binary search situation, but so far it went pretty good. So, all right, I will continue posting these moving forward just so I can get some more practice in.